Yes, I told. Suppose you are
Yeah.
just sitting inside the river. So what will happen? You will flow along the current.
Yes.
Now, if you try to move along this, then river current will take you like this. So you will reach somewhere here.
Yeah.
Now, if you want to cross over directly across the river, so what will happen? In that case, you must start something like this, so that one of the component of your speed will cancel out the flow of river.
Can you explain it again?
Yeah. See, that's why we started like this understanding. If you just flow with the river, so what will happen? We will go along the river. Okay.
Yeah.
Now, if you try to just, I am trying to swim like this, what will happen?
Yeah.
If I will try to swim like this, then river current also has got some speed, so I will be taken like this.
Yeah.
Like, see, river boat problem or river swimmer problem can be well understood by escalator example. Suppose this is a escalator in the mall and it is going up. Okay.
Okay.
Now, if you just stand on the escalator, what will happen? You will go up. Yes. Now,
Yes.
this line is along the escalator stairs. So, if you will walk along this, so suppose your friend is standing at this point. Will you be able to reach him? Escalator is sorry,
No.
person is standing on the ground, just next side of the escalator, and you are going along the stairs. So, will you be able to reach to him?
Yeah.
Will you reach to him?
Is he standing at the top of the escalator?
No,
or
no, no,
on
no,
the
no, no.
ground?
See, suppose this escalator is horizontal. You have to understand. Escalator is horizontal, okay? And
Oh,
he stand.
horizontal. Okay.
Yeah, and
Yeah.
he is standing on the ground, and you are walking along the stairs.
Yes.
Will you be able to reach him?
No. No. No.
Yes. Why? Because escalator will take you to some this place. So your
Yeah.
value. This is what we are trying to say. That is when you will be in the river, and if you will try to cross across it along with this, then you will be taken by the river along this.
Okay. Okay.
Now try to understand if you have to just meet him. So in what direction you will start to walk on the escalator, so that you can reach to this place at some angle like this,
Yeah.
so that escalator will take you to this.
Okay. Okay.
Got the point?
Yes.
So this is why we are saying that a swimmer has to swim along this, so that a sin theta component will be cancelling out this Vr, and Vs cos theta component will help him crossing the river. And that is why we say Vr is equal to Vs sin theta. So this will give you theta. Sin theta is Vr upon Vs, and Vs cos theta is employed in crossing the river. Okay.
Okay. What is VR? Yes.
Vr is river current speed,
Okay.
and Vs is your swimmer speed.
Okay.
So Vs cos theta is employed crossing the river. Okay. Now,
Yeah.
uh, so time taken will be how much? Time taken to cross the river? Time taken to cross the river will be how much? Tell me. If d is the width, so he is traveling with Vs cos theta. And cos theta is how much? Say sin theta we have got as, if this is angle theta, so sin theta we say what? Perpendicular upon hypotenuse.
Yes.
So this will be Vs square minus Vr square.
Yeah.
So this is your T minimum, sorry, T required. So this is nothing but D upon V is cos theta is root under cos theta is root under this upon Vs.
Yes. Yeah. Yeah.
So Vs will get cancelled out and you will get the formula okay.
Yes.
So this is called crossing along the shortest path. This is called crossing the river along shortest path. Okay. And coming to
Yes.
crossing the river in shortest time or least time. So now you think how it will go. And whenever, again I will tell you, whenever you are trying to understand the river boat or river swimmer problem, you must think of escalator because we are very much used to using that. Okay.
Yes.
For me, like any questions if you will give me on river boat or riverman problem, I will solve thinking that yes, I am crossing the escalator, I am going along the escalator, I am going against the escalator. Okay, so one thing it is said that
Okay.
yes, what should be the condition that swimmer must be able to cross the river along the shortest path, means along this path. So mind it, sin theta value is what? It is always less than equal to 1. So VR must be less than VS. Means ki swimmer must be traveling with more than river speed. If it is not so, then never we can never cross the river along the shortest path. Does it
Okay.
make sense?
Yes.
So this is the condition of a speed. Like if they will give you just the data to ask whether he can cross the river along shortest path or not, then you have to check with this one. Okay.
Yes.
Now you think through the escalator example how he is going to cross the river along the in a smallest time. Yes.
Um.
Think once. See, if you are walking on the escalator and you have to just be the next side of the escalator, in what direction you will walk?
So if you're walking on the escalator and
You have to cross the escalator in the least time. So along what direction you will walk?
you'll walk straight.
Yeah, you will walk straight along the direction of stairs.
The escalator. Yeah.
Along this stairs you will walk, yes. But will you be
Yes.
reaching to the opposite point?
Yes.
Will you be reaching to the opposite point? Tell me. Think. Are you going to reach just opposite point or not? Huh?
No, you won't, because
Yes, you will not be reaching to this point. Why? Because escalator will take you like this.
yes.
Escalator is also moving. But yeah, we will be moving along the stairs or along the perpendicular direction. We will try to move along this so that we can cross the river in the shortest time. But our motion will be not be straight, rather than our motion will look like this because of river current.
Okay.
Understood the point?
Yeah.
My God. Other than directly opposite point. Yes?
Yeah.
So this is called drift. This distance is called drift. So first, coming to minimum time required. So what will be the T minimum? Think once. You are crossing, you have traveled how much distance? Tell me. While walking on the stair, how much distance you have traveled? Tell me. See, you are crossing the D only and with a speed of Vs. Suppose think like you are walking on the stair, you are just crossing the stair.
Yeah.
So width is the D and your speed is Vs. So T minimum is nothing but the D by Vs. Very simple.
Okay.
Now, for this much time, water current will drift you to how much distance?
Wait, I have a question.
Uh,
For the first run where we said finding time for the shortest path,
uh-huh.
we did T over Vs cos theta. Here phi is it just d over vs.
That is why I am telling you. Actually, we started in this direction only, na?
Yeah.
See, here what I told, that on a escalator you are walking not along this direction. You are walking, if a stair is, suppose a stair is stationary, then in that case you are walking along this. So yes, component of your velocity is only along the crossing the river or along crossing the escalator, not the whole velocity.
Okay.
But because escalator was moving, so yes, it took you in the same time you took the time in which you went from here to here. In same time, escalator took you from this to this.
Okay.
But here, because we have started along perpendicular direction, so escalator is going to take us ahead.
Yes.
So how much ahead? That is what is our calculation.
Okay.
निकलने के हाँ. Yes, tell me. What will be the drifting? See, river current is drifting in this direction with how much speed? VR. For how much time?
Yeah.
This much. Understood or not?
Yeah, I'm understanding a little bit, but I'm still confused. I don't know why.
No, see, actually, I don't know. A skeletal example is very simple to understand.
It is simple, but for some reason I'm just not able to imagine it in my head.
Okay. Let us take. I have moving escalator. Let me show you. You will get the idea.
Okay.
Okay. Where is search engine? Let's take this. Now see. Cursor is visible. This cursor.
Yes.
See, if you are starting at this point, yes, from this point.
Yeah.
If you walk along the stair, then of course a stair will not take to this place. A stair will take you somewhere here. We are starting at
Right,
this point.
okay.
So if you walk
Yeah.
along the stair, it will take you to some height. That distance
Yes.
is how much? For time you have walked and the speed of the escalator.
Okay. Yeah. Now
So
I
this-
understand.
Okay, so this is what we are trying. Now suppose we wish exactly to come from this point to this point. So of course, suppose in this way, this to this. But person is standing on the, not the moving part, he is standing on the stationary part. And we just want to go against him. So of course we need to
Yes.
walk little bit up. So that something like, if I am trying to walk up, escalator will take me down automatically.
Yeah. Okay.
So this is what I told in the case of moving directly opposite point.
Okay. Okay.
Understood the point? When we are walking
Yeah.
directly opposite, so this person is standing on the stationary part. We have to reach him,
Yeah.
means we will walk along this.
Yes. Okay.
But now we want to cross it in the minimum time. So minimum time means what? We have to go from, of course, if we walk along the escalator, a stair, then only we will cross in the minimum time because width is least in that case.
Yeah.
But yeah, we are not going to reach to this person, rather than we will be drifted forward.
Yes. Okay.
Understood the point?
Yeah.
Yes. Now you can take your question. These are the two cases. Of course, general cases are there also, but general cases are like this only now. that whenever you are walking in any direction, suppose we are walking along this, in general suppose we are walking along this, we have started along this, so yes, and we are reach along this, so what will happen, as you are considering the, that means, so Vs cos theta will be crossing the river,
Okay.
and Vs sin theta will
Drift will be the drift.
along with Vr.
Okay.
So now your drifting speed will be very high. Does it make sense?
Okay. Yeah.
But in previous case, I was walking along this, so this one was becoming negative, and therefore net drift was becoming 0. It was so adjusted that is minus Vs sin theta plus Vr is becoming 0, so the drift becomes 0. Does it make sense now?
Okay. Yeah.
So this is the general case, okay?
Yes.
So here t time required will be how much for crossing?
T over Vs.
No. Which component is crossing? Vs cos theta, okay?
V goes, yeah, cos, yeah, right.
And the drift will be how much? T into Vs sin theta plus
Vr, okay.
got the point?
Yeah.
So this is T upon understood this?
Yes.
Now which question you want? I think your most of the questions are from this only.
Yeah, they are.
So now you can try this, like you have sent me 150 meter north, 150 this, you are capable of swimming at 5 meter per second, you cross 150 meter width river, so that H has a current of 2 meter per second, okay? So what is the velocity of the swimmer if they had directly crossed? Directly crossed means, oh, if they head directly across, yes, they head means ki which one?
Yeah, this one, yeah.
So that's why and this is a theta there, I think is saying, okay?
Yes.
And how long will it take to cross the river if the swimmer heads directly across? Huh? Okay.
Yes. Can you explain the C part? Which direction should the swimmer head to end up directly across?
Which direction should the swimmer head to end up directly across? Now he is not heading perpendicularly, rather than he is crossing perpendicularly, exactly perpendicularly, means this case.
Yes. Okay.
So he has to travel along this angle theta. Sin theta is what? How much? VR by Vs. VR is 2 upon Vs is 5 na. This is your answer.
Yeah.
So theta, now this is what I was saying to your father, that is we are considering this north and this one as west. River current is along east. So if river current is along east, then to cross the river we must travel along northwest. Okay. So theta whatever comes west of north. Okay, west.
So does that mean you have to swim against the current?
Yeah, that is what I was trying to say na. Otherwise how this VR will get neglected? We have to nullify the effect of VR. That is what I was trying to make you understand here. In this case you are supporting the river, but if in this case we are going against the river with one component of the speed, with another component we are trying to cross the river.
Okay.
Understood?
Yes.
So this is the mindset you have to understand, that when your river current is along east, if river current is along east, then you must travel along northwest so that you can try to reach directly opposite point.
Okay.
Understood the point? And that angle theta should be this. Now whatever comes, that will be the answer.
Okay.
So this you have to keep in the mind. Again I am telling this point, that river current along east, then we have to travel along northwest. If river current is along suppose north, then in what direction we will try to cross? Means ki swim. If river current is along north,
South.
and of course in that case this will be the river. You are standing here. In what direction you will cross, so that you can reach to the opposite point, A to B. Suppose this VR was 3 meter per second and VS is 5 meter per second. So in what direction you will cross? Tell me the exact value.
So you are saying the current is going north?
Yeah. Current is going north, and the swimmer is just standing in at point A. He want to cross directly. Take this to guess. Okay. Find the direction and time. See, on ground if you see that, then of course east, west, north, south, they all will lie in horizontal plane. Up, down is in vertical plane. Okay.
Yes.
So now river current is along north. So in what direction you will cross? In what direction you will walk? Data are given. You have to give me the exact answer. And second case also you have to tell me if you want to cross in the minimum time,
Okay, I have a question. So
yes.
if if the current is going north, we discussed that we have to go against the current to
Yes.
head to reach across.
Yes.
So here, would we have to go south?
Yeah. So not exactly south. We have to cross also. So what?
So if you would be going south, then the
No, not. See, if you go along south, then you will never cross it.
yes.
So in what direction I should head so that I should cross the river as well as I should not be drifted. It's very simple. I don't know why you're getting too much confused. Southeast. We have to cross along east as well as along south.
Oh, because you're trying to reach the opposite point.
Yeah,
Okay.
very simple. If you cross directly south, then you will never cross the river. But you have to cross the river also.
So you okay. So you have to go southeast. Okay.
Now tell me the data, the direction. South of east, okay?
Okay.
Now, sin theta is how much? Tell me fast.
So, so we are over.
See, Vs into t is this distance and Vr into t is
Yes.
this distance. So sin theta is how much? Perpendicular upon
VRT
hypotenuse?
over VS.
Yeah, Vrt upon Vst. So t will get cancelled out and you will get what? Vr upon?
Yes.
Vr was how much? 3 and Vs is 5. So this is 3 by 5. Theta is how much? Tell me.
The inverse of this.
Yeah.
It is 37 degrees.
Exactly. Now what
But
should be the...
how is
Yes.
the perpendicular VR into T?
Yeah, because we have started along this, and suppose t time we took to cross the to reach from this to this. In same time
Yeah.
t, river has taken us from this to this.
Yes.
So this is VRT and this is VST. This hypotenuse is VST and perpendicular is VRT.
Okay.
Now t will be how much? So neither we know this distance nor we know this distance, but we know this distance.
Yes.
So now Vs has a component along this. How much? Vs cos theta.
Yeah.
Therefore this chapter needs, that is what I was talking to your father also about this, that this chapter needs time.
Yes.
If unless you solve like one question, two question, three question, then it will become fit. Oh, this is what we have to do.
Yes. Yes.
So d is how much? 200 meter we have taken cos theta. So theta is 37, cos 37 comes 4 by 5. So this will be how much? 4 25 25. 250 second I think.
Yeah.
So this much time it will require to cross him. Okay. Now next part is if the swimmer crosses the river in minimum time, then find the t minimum and drift of the swimmer.
If he's crossing in minimum time, you have to go along with the current.
No. Again, if you go along the current, then of course you will be drifted. You will never cross the river. take the escalator immediately, stick to that escalator figure.
Okay.
Along what direction you will start? Start along. Start along fast. Stairs. Why are you forgetting? We will start along this. Then only we can cross in the minimum time.
Yeah.
So swimmer must start perpendicular to river. So T minimum will be how much? D upon Vs. Just 1 second. Here how this much you are getting? 4 पचे 20. Yeah. Now what will be the drift? Huh? Time T into river current. You are not able to understand?
Actually, I need to do lots of practice before I understand. I'm trying to understand right now.
With the escalator figure, you did not got the thing.
I did get it after seeing the video. I got it.
Yeah. So see what that is why I have written the complete statement so that you can get it. Okay. So while reading just this river current, you can write means ki once you can write river instead of river current escalator. Okay.
Okay.
And read this again and again and see the video. And sometimes you know you can go with your father to some mall and you can try there also. It's very easy.
Okay.
Because unless you practicalize it in your mind, it's very difficult.
Yes.
But questions are easy, you know. Actually, I have done whenever I go to mall na, if some of my students I get, I explain them everything. People are watching what this person is doing. But yeah,
Okay.
this is very good. This is very good. Like now they may ask you ki what will be the final position with respect to this east. So displacement of my enemy will be like this because he has tried along this, but he has reached here. So this angle theta will be how much? Tell me. This is your VRT. This is your VST. Because I started with VS along this, river took me with VR along this, and of course both of us have taken same time.
Yes.
So again tan theta will be how much?
VRT over VST.
So VR upon VS. VR was how much? 3. VS is 5. So can you tell me what will be the value of theta?
31 degrees.
31 degree. So swimmer will reach to, so final position of swimmer is how much? This is east,
Yes.
and this is along north.
Yeah.
So north of east.
East. Okay.
North of east, 31 degree. So
One question.
yes.
Sorry. No, you can complete this question first, then I'll ask.
Yeah, this completed.
Okay. There was a similar question. I think easier, but I was having trouble finding the direction for that one. It was the second question.
This
It was in the
direction I have
middle.
written correct, na?
Yeah.
East 31 degree north.
Yes.
Yeah, because this I get
It
confused.
is.
Okay, yeah, which question tell me?
It is in the second picture, that
Yeah.
the blue box, and it's the second question. I mean the first question page, number 2.
Acha, number 2 question, yeah. An airline flies due north. Yes.
So here,
This question only, na?
yeah, this one only.
The airplane fly due north over Sudbury. Okay, Sudbury with velocity related to the air this much, and with a wind velocity this much. Calculate the speed and direction of the airplane. Yeah, tell me what you did. Now again, see, in the case of when we are walking along on escalator, okay, so VR is the escalator speed, and whatever speed we are walking on the escalator, that is our speed. Here in the case of
Yes.
flight also, flight is walking on what? Is walking on air.
Here.
So yes, it's this Vs is nothing but the velocity of flight, and VR is nothing but the velocity of wind.
Okay.
Now, airplane flies due north. He is flying due north. So this is your V airplane. So flight time VF, okay?
Yes.
With velocity related to it, and its velocity is how much? 235.
Yeah.
And a wind velocity of 65 km per hour northeast. It is northeast. So wind is blowing like this. So this is your VW at 45 degree.
Okay.
Because direction is not given, so northeast means 45 degree. Calculate the speed and direction of the airplane. So now this is 65.
So when the angle is not given, do you always have to assume 45
Yeah,
degrees?
if northeast or northwest or southwest, something like that, it is said, but angle is not given, then we assume 45 degree exactly.
Okay.
Yeah. Now this VW will have two component, one along the flight, another perpendicular to flight. Use कर लगी. Understood?
Yes.
So tell me what are these values?
So the vertical would be
Both will be equal.
65
upon root 2. Do it and tell me how much is it coming.
is 45.5. 9.
So 45.9 and so 46 can I take?
Yeah.
Here also 46. Now net upward speed is how much?
Three,
चलो let's see.
60, 65.
No, this is the along north and this is along east. So flight will look like moving along this, the resultant of these two. Okay.
How did you get the 281?
Yeah, I added into 235.
So you did 235 plus 46.
Yeah. This is what I was saying. Na, see, like if you're walking along this, I told what VR is nothing but the velocity of uh, wind, VW. So
Yeah.
what I was doing? See, adding my
Right.
component along the river. Now in this
Yes.
case, means it has simplified that as river current is something like this, and you are walking along this. So river current we are taking component as we used to do for the person.
Okay.
So do it. Where is it? Yeah. So tan theta will be how much? 281 upon 46. How much is it coming? You just do it. I'm coming in 1
81
second.
degrees.
Oh, 81 degree. Yeah. What is the answer? 81 degree.
81 degrees.
81 degree north of east. So this is 81 degree north of east. Yeah, correct.
Can you explain the direction again? This is the only thing I was confused about.
Yeah, see. First of all, what we did. First of all, you have to understand why we did like this. Because wind was like this, and you are
Yes.
walking on the wind. Like
Yeah.
if you just stand, if the flight is just standing in the wind, so what will happen? It will go along the wind like this.
Yes.
But now he has also started to walk. Like it's like you are walking on moving escalator. So
Yes.
your speed will increase very high with high magnitude if you directly walk straight up, and
Yes.
escalator is also going up. So this is,
Yeah.
but we are not walking along the wind. He is walking at some angle with the wind. So
Yes.
one component will add up the speed, another component will drift it.
Okay.
So this is the net vertical speed, and this is the net drifting speed.
Okay.
Then tan theta we do it. Vertical velocity is 281. This is 281 perpendicular, and base is 46. Okay.
Yes.
Like here that we have taken. If they would have asked you what is the direction along which you will reach, so you will be moving something like this. Yes.
Yeah. Yeah.
So this if t is the total time taken that you have went, so vs into t is this hypotenuse,
Yes.
and vs, or you can say perpendicular will be v cos theta into t,
Yes.
and this will be v sin theta plus vr into t. Tan theta will be ratio of these two. Okay.
Okay.
So similarly here also you are doing. Yeah, tell me further. So slowly, is it getting clarified or you are getting more confused?
It's getting clarified, but I think I have to do lots of practice to
Yeah.
understand.
But I will tell you, of course, you must see this whenever you get confused. You just go through this recording, because again and again I am stressing on the term that how we have to consider this. Okay, once we also saw the video,
Yes.
so that because do a lot of question and take the help of this video to clarify it whenever you get stuck up with the direction. Okay, I will guarantee you,
Yeah.
you'll not have even a single doubt.
Okay.
Yeah, tell me next question.
Can we do the fifth question?
Yeah, fifth. Okay. A large ferry boat is moving north. So yeah, again he is moving along north. Okay, let me first write moving north 44 meter per second with respect to the shore. So now he is walking north with respect to the shore. Means that this is the resultant speed. If this is the shore
Yes.
and you are walking perpendicularly, means that this is what your angle is not changing. Means that you are crossing
Yes.
the river along shortest path. Okay,
Okay.
and its speed is. This will get more clarified if I read the complete question, that whether I am right or wrong. Okay.
Okay.
While a child is running on the deck at a speed of 3 meters per second. Okay. Determine the velocity of the child relative to Earth. And the child is running in the following directions with respect to the deck of the boat. Just 1 second. A large ferry boat is moving north at 4 meters per second with respect to the shore. Okay. While a child is running on the deck. Deck means what?
It's just a surface of the ship
Okay.
or the boat.
Okay.
Yeah.
Means it's a kind of something surface connected to river source. Or deck is the floor of means ki boat.
Yeah, floor of the boat.
Oh, means ki on the boat only this child is walking. Yes.
Yeah.
Okay. So child's speed is also given. First case they have taken north. So of course boat is heading north and child is also
Yes.
walking along north. So of course it's kind of same thing that I told you, that you are walking on the escalator upward and escalator is moving upward. So suppose you are walking with a speed of 2 meters per second and escalator is walking with a speed of 3 meters per second upward. So what will be the your total speed with respect to ground? Understood the point? Suppose escalator is going up with a 2 meters per second. Yes, and you are walking
Yes.
on this escalator with 3 meters per second, and I am standing out of the escalator. So how much speed I will be observing you? With what speed you are moving for me?
5 meters per second.
Yeah. So this is moving along north. This one is also moving along north. This one is moving with how much? 3 meters per second, and this one is moving with 4 meters per second. So we can say velocity of child with boat with respect to boat.
7 meters per second.
Yeah, velocity of child with respect to boat is what? Velocity of child minus velocity of boat.
Yes.
And both are along north. So velocity of child is 3 and velocity of boat is how much? No, velocity of child has to be calculated. Mind it. Velocity of child with respect to ground is to be calculated. Velocity of boat is how much? 4 meter per second north. And
Yes.
velocity of child on boat is how much? 3
meter
per second north. So take it this direction. VC will be how much?
7 meter per second.
Because both were north, so it just got added up. Okay.
Yes.
Now second part they are asking, if it travels along south. So now child is walking along south.
So wouldn't it just be the negative?
Yeah. Velocity of child with respect to boat is now how much? They have told 3 meter per second south. So velocity of child minus velocity of boat.
Yeah.
So velocity of child with respect to ground will look like velocity of boat with respect to ground, which is how much? Velocity of boat is how much?
4 meter per second.
4 meter per second north. So of course south is negative of north.
Yes.
And this is your relative velocity. So that is why your father was saying that he has doubts in relative motion. So understood how is it getting done?
Yes.
Now next part is he is walking along east. So now again same thing. Velocity of child with respect to boat is how much? 3 meter per
3
second
meter per
east.
second.
Which is
Yes.
velocity of child minus velocity of boat.
Yes.
So velocity of child will be how much? Velocity of boat plus 3 meter per second.
Okay.
And this is north. So one is along north. This is 4 meter per second. Along east it is 3 meter per second. So resultant will be how much? Triangle of vector
5
addition.
meter per
Yeah.
second.
Now what direction? Theta calculated.
Um, Tan of it is 53 degrees.
Yeah. So tan theta is 4 by 3. And theta is 53 degree. So we can say 5 meter per second 53 degree.
East of north.
No. This is north. This is east. So north of east. Okay.
Yes.
And same thing they have given. They have taken this angle. See. This will be 37
Okay.
degree east of
Yes.
north. East of north.
Oh. Okay.
Does it make sense or not?
Yeah, it does.
Any more?
No, that's it.
Okay. I will send you the recording.
Yeah. Okay.
Okay, thank you.
Okay, thank you.
PDF also you want?